This episode is brought to you by my friends at Patreon. If you'd like to join them and get early audios of upcoming episodes, please see the link in the description. And, once again, by Singularity G3, whose images have given life to this journey since it began. When I suggested Nebulae as my option for my next You Are Here video, what I intended was a continuation of Kevin Jardine's Nebula and Star Cluster map. But upon glancing at said map, I realized with dawning horror that there weren't actually many nebulae in it. And so, peering ruefully at my looming Christmas deadline, I hurriedly cobbed together a list of the nearest nebulae to our solar system and worked from there. You might assume that such a list would already exist, but from what I can tell, no. The classification of nebulae appears designed to be as confusing as possible, no doubt a legacy of the time when nebula meant anything not moving in the sky that isn't a star. Back then, galaxies and star clusters were nebulae, as well as the more appropriate clouds. If you think it's simpler these days, nope. Are Herbig-Haro objects, the jets emanating from newborn stars, nebulae? Some say yes, some say no. If the Orion Nebula is a nebula, is the Orion molecular cloud, of which it is a part, also a nebula? Or are molecular clouds and nebulae distinct? A planetary nebula is the last breath of a dying star, while the solar nebula is the material around the sun from which our planets formed. The nebula from which our sun formed is called the presolar nebula, while an extrasolar nebula is not, as you would assume, any nebula beyond our solar system, but a solar nebula around another star. Will this be a comprehensive list? Almost certainly not. I beseech anyone with greater knowledge than myself on this topic to publish one. One thing I should clear up before I begin is that however amazing the finale of Wrath of Khan was, nebulae are not space fog. The smallest nebulae are thousands of AU in extent, and most are light years across. If you were suspended in a nebula, the view would appear little different from the rest of the universe. A typical nebula has a particle density of a few hundred per cubic centimeter, about what can be generated in artificial vacuums on Earth. The beloved contours and billows gifted by the Hubble Space Telescope are only visible at extreme distance. Nebulae are among the farthest objects observed in our galaxy, and have even been imaged in other galaxies. So don't expect our nebular neighborhood to be cozy. What is the nearest nebula to Earth, then? Don't ask Google. No, instead trawl around the internet for an hour or two until you stumble across the Maia Nebula. There are a few sights in the night sky more alluring and more mythically charged than the Pleiades. Even to the naked eye, and in the faded, choked skies of the modern world, their ethereal presence strikes a deep chord in the human soul. This is largely due to the reflection nebula the cluster of young stars is currently traveling through, which grants it the appearance of an otherworldly bridal procession. A reflection nebula is defined as thick enough to scatter light, but not charged enough to emit its own light. Its blue color is due to carbon dust, which refracts the light from the stars in much the same way as the molecules in our atmosphere refract sunlight. It is not believed to be the remains of the Pleiades' stellar nursery, but rather an inconvenient obstacle the stars are currently plowing through. As with most nebulae, the veil draping the Pleiades is confusingly named. despite all the stars apparently residing within the same cloud, each star is granted a separately identified fragment as its own, usually bearing its name. The closest, at 118 parsecs, is the cloud surrounding the fourth brightest of the Pleiades, Maia. Of all the Pleiades, Maia has the greatest cultural imprint. She was the mother of Hermes, who famously stole Apollo's cattle and invented the lyre before she had woken from her postnatal sleep. Her name became an honorific for midwives and other good mothers, and was given to the month of May, and even made its way into paleontology, with many maternal creatures granted the name Maia. The star Maia is a blue B-type giant with 4 times the mass, double the surface temperature, and 500 times the luminosity of the Sun. It lies less than 1/10 of a parsec behind its nebula. Moving out, at 125 parsecs, we arrive at Barnard 68. Followers of my channel will likely be familiar with Edward Emerson Barnard, whose rags to relative riches story I outlined in my tale of his eponymous star. Aside from said star, and the discovery of the 5th moon of Jupiter, Barnard's legacy lies in a catalogue of so-called dark nebulae, first published in 1919, and then posthumously revised in 1927. The catalogue lists a total of 359 so-called Barnard objects, all of which, like Messier objects, retain his name, though, unlike Messier objects, none of them turned out to be galaxies. Rather, dark nebulae, or absorption nebulae, are standard interstellar clouds so choked with stardust that they block out any light from background stars. Barnard 68 lies in the constellation Ophiuchus. It forms part of a chain with fellow globules Barnard 69 and Barnard 71, suggesting they were part of a filament that dispersed. It is a particular subtype of dark nebula known as a Bok globule, an isolated, small and round dark nebula, about 2 solar masses and half a light year across, named for Dutch-American astronomer Bartholomeus Bok, who was the first to propose that such isolated, small, opaque nebulae may be, quote, cocoons in which star formation takes place. At a mere 125 parsecs from Earth, Barnard 68 is an excellent test for this hypothesis, and, initially at least, it didn't back it up. All the evidence seemed to suggest that Barnard 68 was stable, with the heat from colliding particles balancing out the gravitational collapse, a bit like a balloon, with maps of oscillations suggesting that it had remained stable for 3 million years, a dozen times longer than predicted. However, in 2009, a joint Spanish-German team proposed that Barnard 68 was in the process of being struck by a smaller nebular, quote, bullet that would, in about 200,000 years, collapse the balloon into a new star. Don't get too excited for our descendants, though. Barnard 68 may be the closest dark nebula to Earth, but it is still 125 parsecs away. At that distance, a star like our Sun would be invisible to the naked eye. Nearly the exact same distance, but just south in Scorpius, we find IC 4605, a part of the larger Rho Ophiuchi cloud, which I mentioned in one of my earlier videos. IC 4605 is a reflection nebula standing in the way of the bright blue star 22 Scorpii, and thus scatters its light in a most becoming way. Our next stop on this journey, at around 130 parsecs, is the Corona Australis molecular cloud, located to the left of Scorpius in the constellation Corona Australis, the Southern Crown, which, unusually for a southern constellation, actually resembles what it's named for. The Corona Australis molecular cloud, known to its friends as CRA, is in a dead heat race with the Rho Ophiuchi molecular cloud for the closest star-forming region to Earth, which, given the general imprecision of astronomical measurements, is unlikely to conclude anytime soon. CRA is about 820 solar masses and about 12 parsecs across. You may notice upon glancing at its image that it vaguely resembles a comet, or at least a medieval sketch of one, The tendrils emanating from its nucleus, known as the coronet, formed in a similar way to a comet's tail, strung along by the interstellar magnetic field. The coronet, an open cluster comprising several variable stars, appears to be the center for star formation in the nebula, with many highly evolved pre-solar cores observed within it. At about 135 parsecs, we return to the Pleiades, and to the meekest and most penitent of the seven sisters, Merope. Her name means with face turned, because she, as the faintest of the Pleiades, hid her face in shame because, while her sisters had married gods, she had married a mortal, Sisyphus. So yeah, that worked out. Merope the star is another B-type subgiant 800 times as luminous as the Sun. Despite being described as the faintest of the seven sisters, she is only the fifth faintest, outshining her siblings, Taygeta and Pleione. She is a Beta Cephei variable, a class of hot, blue, slightly aged stars that pulsate slightly every half day or so. The reason for this pulsation is believed to be due to an odd property of iron, which gets darker and more opaque at temperatures above 200,000 kelvins. This opacity absorbs light, which increases pressure, pushing the star outwards. Her nebula is striking in that it contains another nebula within it, called, for obvious reasons, Barnard's Merope Nebula. It lies just 3,500 AU from Merope, and as a result is 15 times brighter than the surrounding Pleiades nebula. Despite resembling a Bok globule, it does not appear to possess a protostar at its center, and is classified as a reflection nebula, like the rest of the Pleiades cloud. Despite its proximity to Merope, it does not appear to be gravitationally bound to the Pleiades. Its motion suggests it originated in the Taurus molecular cloud, of which the cloud enveloping the Pleiades is believed to be a distant outlier. Speaking of, at 140 parsecs, we arrive at the Taurus molecular cloud, which I've already covered in my previous video. So, see above and let's move on. Also, there are other Pleiades nebulae, but I can't find any information on them, and if I went back to them every few parsecs, this video would get, well, Sisyphean. So let's just declare that lovely troop covered. So, hands clapped and dusted, where are we? Why, at 180 parsecs, the Coalsack, naturally. Nestled in the crook of the Southern Cross, the Coalsack is, after the Great Rift, arguably the most famous dark nebula in the night sky, and forms part of all dark constellations envisioned by Southern Hemisphere cultures. Most notably, it forms the head of the Emu of the Sky, the most recognized figure in Aboriginal astronomy. Among the Darug people of southeastern Australia, it comprised the corpse of Chingal, the first great emu, who ate people, and so was subdued in a cosmic battle by the brothers Gla, known to us as Alpha and Beta Centauri. Among the Wardaman people of the Northern Territory, the Coalsack was the head and shoulders of the lawman, who watched over the world to ensure laws were followed. Among the Inca, it was the heavenly Tinamu, a small kiwi-like bird that is the closest living relative to the extinct moas. The San of the Western Kalahari rather concisely describe it as the old bag in the night. Europeans didn't likely see it until 1499, when it gradually acquired the nickname the Black Magellanic Cloud, a name whose troublesome history I will cover when I finally reach the actual Magellanic Clouds. By the 19th century, all dark nebulae were referred to as Coalsacks, with this one referred to as the Southern Coalsack, and the Great Rift the Northern Coalsack. The Coalsack is still called the Southern Coalsack today, but with the more poetic Great Rift gaining ground, that is becoming less and less frequent. About 11 parsecs across, and comprising about 3,500 solar masses of material, which makes it substantially larger than the more famous Orion Nebula, the Coalsack is, like Barnard 68, a likely site for future star formation. A study in 2011 found that its veil hid multiple prestellar cores, many of which showed signs of infalling material. One of these cores might be the result of a recent merger that formed the Coalsack, and the pressure from the event could lead to star formation in as little as 40,000 years. At about 190 parsecs, the distance to this cloud has been subject to maddening debate. I'm going with 2020 data. We find the Chamaeleon cloud complex, located in the far southern constellation of Chamaeleon, which, like most southern constellations, bears little to no resemblance to its namesake. It was named in 1596 by Dutch navigators Pieter Dirkzoon Keizer and Frederik de Houtman in their inaugural expedition to the East Indies, during which they also named such constellations as Musca, Tucana, and Volans, all of which bear at least a squinting resemblance to their supposed inspirations. So you'd think they would have come up with something less fanciful. The complex itself is about 20 parsecs long and comprises 6,000 solar masses of material, contained in 3 dark clouds, Chamaeleon 1, Chamaeleon 2, and Chamaeleon 3. 1 and 2 show signs of star formation, but 3 appears to have, for now at least, gone dormant. The Musca dark cloud in the adjoining constellation of Musca the Mouse may have a tenuous connection to this complex as well. The clouds are believed to have formed from the expansion of the local bubble, an hourglass-shaped cavity in the interstellar medium about 300 parsecs across, that our Sun is currently traveling through, likely created by supernovae in the Pleiades about 20 million years ago. The Chamaeleon 1 dark cloud is home to between 180 and 300 young stars, one of which, the massive X-ray source HD 97300, illuminates the reflection nebula IC 2631, also not confusingly at all called the Chamaeleon cloud. Many of the stars are T Tauri stars, blazing protostars that have not yet commenced fusion in their cores and shine by gravitational compression. Both clouds contain a number of objects, stellar and substellar, with surrounding disks. At 200 parsecs, we arrive at the Pipe Nebula. Like the Chamaeleon cloud complex, the Pipe Nebula is believed to be part of the Scorpius-Centaurus association, which in my first video in this series I claimed was part of the Radcliffe Wave, a galactic ripple of star formation that comprises much of our local Orion arm of the Milky Way. However, new evidence from Gaia suggests it may be part of an as-yet imprecisely defined secondary feature called the Split, a spur of gas and dust connecting the Orion arm with the Perseus arm. The Pipe is a dark nebula that in turn forms the hindquarters of the Dark Horse Nebula, not to be confused with the Horsehead Nebula, which is also a dark nebula, a tributary of the Milky Way's Great Rift, obscuring its central bulge. It is, in fact, a complex of several dark nebulae: Barnard 59, 65, 66, 67, and 78. Barnard 78 comprises the Pipe's bowl, while the others, blurred into a chain of clouds known as a dust lane, comprise the stem. The nebula comprises about 3,000 solar masses of material, and appears largely inert. Only Barnard 59 shows any signs of star formation. Also at 200 parsecs, but farther along the zodiac in Aquarius, we find the Helix Nebula. Remember when I said do not Google the nearest nebula to Earth? Well, if you do, the helix is what you get. I hope I have managed to show that the helix is not in fact the nearest nebula to Earth. It is, however, the nearest planetary nebula to Earth. Despite what you may be imagining, a planetary nebula is not the cloud of gas and dust around a star out of which planets form. That's a protoplanetary disk, also called a solar or extrasolar nebula. A planetary nebula is the veil of gas and dust cast off from a dying low-mass star like the Sun, as it forms into a white dwarf. They're called planetary nebulae because, through early telescopes, their circular exhalations resembled planets, leading 18th century astronomers to assume they were observing gas giants. Planetary nebulae do not persist for very long, about 20,000 years on average, and thus are extremely rare. Only about 3,000 have been recorded in our galaxy so far. Despite this, it is likely that their expelled elements, fused in the core of their star when it was alive, enriched the protoplanetary disks of newborn stars, allowing them to form planets and thus indirectly earning their name. The Helix is a fairly archetypal planetary nebula, closely resembling famous examples like the Cat's Eye Nebula and the Ring Nebula. Though at around 6 light-years across, it is about double average size for a nebula of its type. The light from its still young white dwarf, seething with a surface temperature of 120,000 kelvins, causes the gases of its veil to glow in every color of the rainbow. If we assume that its gas has always been expanding at 31 kilometers per second, then it is about 10,600 years old. The helix has a complex structure. It is flattened on one side, as its expansion is shaped and molded by the winds of the interstellar medium. Tidal forces from its central white dwarf distort it into a prolate spheroid. Some have suggested it is a bipolar nebula, only viewed from a particular angle. The Helix was the first planetary nebula revealed to possess so-called cometary knots, a feature believed common to all planetary nebulae, but so far only visible in the nearest examples. Like planetary nebulae, cometary knots are named for their shape, not their nature, and thus have nothing to do with comets. They are trails of ionized gas pushed by light pressure. No one knows how they form. Are they survivors of the last days of their star's life? Or did its white dwarf corpse somehow inject them into the nebula after death? At 240 parsecs, and on the other side of the zodiac in Virgo, we find another planetary nebula, Able 36, which, despite its closeness and average size for its type, 1.5 light-years, is surprisingly dim. Analysis of its halo of material suggests that, rather than being of stellar origin, it is typical of the material surrounding space. Also, its central star is not a white dwarf, but a hot subdwarf, a star that has not quite finished its final transformation into a white dwarf. Only a fraction of hot subdwarfs have been recorded as planetary nebulae. It does make me wonder, are planetary nebulae of Able 36's type actually planetary nebulae at all, or are they just dying stars lighting up surrounding gas clouds? Our next stop, at 250 parsecs, takes us to the southern constellation of Vela, the Sail, once part of the larger constellation representing the Argo, of Argonauts fame. Within it, we find this seemingly unassuming nebula, NGC 2736, also known as the Pencil Nebula. Just 3 parsecs long, this bizarre, dull ray of cloud may not appear much at first glance, but becomes far more interesting when you consider that astronomers believe it is essentially, well, this, only on a far grander scale. It is the shock wave from the supernova that produced the Vela pulsar, 44 parsecs beyond it. It is expanding at a rate of 179 kilometers per second, approaching the speed of the Parker Solar Probe, the fastest spacecraft ever launched by humanity, and yet from our perspective appears motionless. Such is the nature of space. The Vela supernova remnant, of which the Pencil Nebula is a very distant part, is about 30 parsecs across and somewhat overheated in its southern region, suggesting it may be colliding with the superbubble generated by the Wolf-Rayet star Gamma 2 Velorum. Wolf-Rayets of Gamma Velorum's type are gigantic stars, thousands of times more luminous than the Sun, that are moving off the main sequence and beginning to fuse elements heavier than hydrogen. The supernova that created the Vela Nebula is believed to have occurred about 11,000 years ago, when our ancestors were just figuring out agriculture. This makes it middle-aged for a supernova remnant, and in about 11,000 years' time, it will dissipate into the void. As for the Vela pulsar itself, it is about 19 kilometers across, spins about 11 times a second, and was, in 1968, the first pulsar found inside a supernova remnant, showing that pulsars are created by supernovae. The pulsar is surrounded by a wind nebula, a nebula of highly magnetized plasma, whipped to relativistic speeds by magnetic fields 2 million times stronger than the strongest superconducting electromagnets. In the gamma-ray sky, it is one of the brightest objects visible, alongside the nearby Crab Nebula pulsar, the Geminga pulsar, and the very inaptly named 3C452.3, a quasar 2.36 gigaparsecs away. yet so bright it outshines even our own galaxy's pulsar. Speaking of, the Geminga pulsar also lies roughly 250 parsecs from Earth, but back in the zodiac in the constellation of Gemini. Its name is a portmanteau of Gemini and gamma ray source, but also a play on the word for "it's not there" in the dialect of Milan. The reason for this is that, for 2 decades, even though Geminga was observable in gamma and X-ray light, its source remained unidentified until the Rosat satellite detected a 2-second periodicity in its source, identifying it as a pulsar. While its remnant nebula has long since dispersed, its parent supernova having occurred round about the time that humans were first calling themselves a species, Geminga does possess a wind nebula, though one apparently distended like a tail of a comet. It is also surrounded by a halo of gamma radiation so vast that, were it visible to the naked eye, it would blot out several constellations. Okay, I think I need to stop here. I know this is somewhat short for a You Are Here video, but I'm on a bit of a Christmas deadline and need to get this out before the end of the month. There are many more nebula to go, and if you, my fellow seekers, wish me to continue this series, let me know in the comments. I wish you all a very Merry Christmas, and we'll see you again in the new year.